right, let's see if you did better this time. Feel more confident? All right, where'd you put your center? At 1, 2. Where'd you put your vertices? You started here, and this told you to count sideways. So -1, so count sideways 2. So that looks okay? Sorry, no. Just put it away. Don't get it out in this class. Don't let it tempt you. We're going to go up and down 3. How long is my major axis? 6. My minor axis is 4. My foci are here somewhere. That's my major axis. What's this distance? Square root of 5. So I'm going to start right here, and I'm going to go up the square root of 5. Now somebody asked me yesterday, okay, so it's root 5. How do you know whether that goes with the x or the y? Well, how do I know which one it goes with? I'm going up, right? Which direction is that? Y. So 1, 2 plus root 5, and 1, 2 minus root 5. What's our eccentricity? Root 5 over 3. It's this distance, root 5, over this distance, which is 3. Okay, I heard some, Did you just do dumb stuff that you know better?
Yeah.
Just don't count this. Never count the quiz.
That is the
Completion point.
No.
Okay.
We tried all of them.
All right, well, today we're going to look at the hyperbola. Oh, before I do that. So let's start simple. How do I know that is not an ellipse? What is different about this equation? It's a minus. It's a minus. Now, the good news is that even though we're doing an entirely different shape, most everything stays the same as with an ellipse. For example, where's the center? 0, 0. If this were an ellipse, this 9 would tell you to do what? Left and right 3. So I'm going to do that. And if this were an ellipse, that 2 would tell you, or that 4, I mean, sorry, that 4 would tell you up and down 2. Harry?
Yes.
Now, on the quiz, when you got those 4 points plotted, you connected them with a nice little ellipse, right? This time, I want you to connect them with a box. Now, you probably remember this from last year. So I plotted the same points in the same way that I would have with an ellipse, but I'm connecting them with a box. Now, I'm going to draw in the diagonals of that box. They're supposed to be straight lines. those diagonals are called the asymptotes. And we're going to find their equations in a minute. Now, you know we're sketching a hyperbola. So our choices are to sketch in this hyperbola or to sketch in this hyperbola, right? Does anybody happen to, have a guess or remember which one it is in this case? You are right, Redor, and how do we know that? Actually, it doesn't have anything to do with size, although that's a good thought. It's not because x has a bigger denominator, it's because x comes first in the equation. If this had been y squared minus x squared, it wouldn't matter what the numbers were in the denominator. This one would open up and down. But because x comes first, we are sketching in this hyperbola. Okay? Now, this axis right here that joins the vertices, these 2 points are the vertices of the hyperbola. These points are nothing. They're just out there to help me make the box. These are the vertices. There are 2 of them. The segment that joins the vertices is called the transverse axis. And you'll remember that because in the word transverse, you kind of see vertices. So the length of your transverse axis is 6. This axis, which has nothing to do with anything except building the box, is called the conjugate axis. And the conjugate axis in this problem is for Newton's law. Now I want to emphasize what Newton was talking about. In terms of transverse and conjugate, length is irrelevant. I mean, it doesn't matter which one's bigger. Transverse joins the vertices, conjugate is the other one. Now, any idea where your focus points might be in a hyperbola? On the transverse axis, in here somewhere, right? Does that make sense to you? Just like in a parabola, they're inside the curve. They're going to be in here someplace. You guys are funny. I wish you could all be up here looking out at this. Because it is so clear that no one gives a rip about the foci of the hyperbola right now. But we're going to persevere. The distance between the center and the focus. The distance between the center and the focus of a hyperbola. I'll just tell you, tell me how I did it. In this problem, it's root 13.
You add the 2.
I add the denominators and take the square root. Okay, remember how you did it in an ellipse? How did you do it in an ellipse? Subtract it. And that makes sense, kids, because in an ellipse, the foci have to be closer than the vertices. So you're going to subtract those denominators to get a smaller number. In a hyperbola, they have to be pushed past the vertices. So you're going to add your denominators to get a bigger number. So this coordinate right here, starting at the center, this would be negative root 13, comma 0, and this would be root 13, comma 0. what your eccentricity is? Root 13. Yep, just like an ellipse. Over what do you think?
3.
3. Perfect. That's it. It's the distance from the center to the focus divided by the distance from the center to the vertex. Just like in an ellipse. Center to focus over center to vertex. Tell me about the size of this fraction. It'll always be greater than 1. Okay? So right now, you know the eccentricity of a hyperbola is always bigger than 1. The eccentricity of an ellipse is always less than 1. And the eccentricity of a parabola is 1. Right? Parabola, eccentricity is 1. Ellipse, less than 1. Hyperbola, bigger than 1. All right, we're almost done. The only thing we have yet to do is to write the equations of these asymptotes. Now, your asymptotes are lines. How do we write equations of lines? We need the slope and we need a point. Now let's take a look at these asymptotes. We know actually quite a few points, but what's one point we know every single time? Well, we know the center, right? Happens to be 0, 0, but the asymptotes are going to cross at the center, so we'll always have the center. So our point for us is going to be 0, 0, because that happens to be the center. In a minute we'll do one that's not at the center. Now what about the slope? Think about building this box. How far up did we go? 2. How far over did we go? 3. So the slope is plus or minus 2/3. For this asymptote, it's up to right 3. For this asymptote, it's up to left 3. So one slope will be positive and one slope will be negative. So because the origin is included, these are easy. Your asymptotes are just y equals plus or minus 2/3 x. Now in a minute, we're going to do one not at the origin, and that's going to get a little more work involved. Okay. So again, new figure, some new vocabulary, but most everything is the same as an ellipse. All right. Let's try one now that's not centered at the origin. Problems here. Okay, you're walking down the hallway, you find this equation. How do you know it's a hyperbola? 2 minus 9. That's right. You got your squared terms, but they're not being added, they are being subtracted.
You would do that.
So what's your thought? Complete the square. So we're going to take our y's. Harry?
Well, I was talking about x's and y's.
Okay, we'll turn around this way.
Okay.
Zip your lip. So we have 4y squared plus 6y plus blank. We're going to complete the square. Now be careful. When you put your x's together, you're going to take out a -9, right? So you're going to have x squared minus 2x. Now you can say to me, oh, Mrs. Ford, it's no big deal, it's just a sign. It's a huge deal, because if you miss this, your center will be off, and if your center is off,
Everything is
forget it.
off.
Yeah, it's all gone. So you really have to be careful on your arithmetic. We factored out a -9, so this became x squared minus 2x. All right, what goes here? 9, but on the other side, I'll have to put, what goes here? Half of 2 is 1, squared is 1. But on the other side, I'll put
Would that be minus 9?
-9. -9 times 1. Okay, now what? Just like we did before, we're going to divide by 36. And everything works out beautifully because I stay up late at night and write these things. Okay? All right, let's start in. I'm going to go ahead and erase some of this. I really draw this guy. Okay, where's my center? 1, -3. Now, here is another potential pitfall. The order of the equation has the y first, right? Which is okay. But that doesn't change your ordered pairs. Your ordered pairs have to be x comma y. So your center is at 1, -3. Now, where would your vertices be if this were an ellipse? You would count up and down 3 and sideways 2. So let's do that. Up and down 3. And sideways 2. Now don't connect those with an oval though. What do we connect those with? A box. And then we draw in the diagonals of the box. And now we need to draw in our curve, either sideways or up and down. Y comes first, so it's going to be up and down. Which means that as we are filling in the the blanks of information, you've already filled in your center, now you can fill in your vertices. What are your vertices? 1, 0, 1, -6. Those are your vertices. This then is your transverse axis. It is 6. And this is your conjugate axis, 4. Everybody still with me?
The transverse is always the
Vertices. Vertices. Joins the vertices. Now your foci are inside the hyperbola curves. How far is it from the center to the focus in this hyperbola? Square root of 13. So I want you to start right here This is the center. Everything starts at the center. Start at the center and go up through 13. Where would you be? What would be this point? One comma, -3 plus root 13. And this one would be 1 comma, -3 minus root 13. What's your eccentricity? 13/3. Yep, perfect. Again, your eccentricity is the distance from the center to the focus, which you just figured out was root 13. Distance center to focus, divided by the distance from the center to the vertex. All right, we're all done except for our asymptotes. So now we need to write the equations of our asymptotes. So I'm going to erase some of this over here. Old work. What's the slope of my asymptotes? When I built the box, how far up did I go?
3.
And over? So my slope is 3/2 or -3/2. Yeah, got 2 of them, so I need 2 equations. What point am I going to use? I'm going to use my center, which is 1, -3. Now you're going to write the equation of these lines, and you're going to do it however you're comfortable. If you like slope-intercept, you'll use y equals mx plus b. I happen to be a point sloper, so I will do y plus 3 equals 3/2 x minus 1. That's the point slope form of a line. If you don't like that, you do y equals mx plus b. You'll say -3 equals 3/2 times 1 plus b, and you'll figure out b. I'll simplify here. So both of us, no matter how we do the problem, should end up with one asymptote being y equals 3/2 x minus 9/2. And then we'll repeat the process. There's no shortcutting it. You've got to do it separately. Unless you're at the origin, you have got to do it separately. So I got -3/2 x minus 3/2. So let's make sure we can find everything we need for a hyperbola. We need to be able to find the center. We need the vertices. We need the foci. We need the length of the transverse and the length of the conjugate axes. We need the equations of the asymptotes. And we need the eccentricity. I think we found everything. All right. Okay, I'm going to give you one to work on with your partner. Then we'll check it, and then we'll be done for the day. Why don't you get started on this with your partner?
This Grace working there?
See if you can get it in standard form. It should work out, because I did plan for too.
There's crumbs. I wasn't trying to like it. I ate the picture. Yes. Yes.
So asymptotes papers, okay.
Say no.
No, that's, what are we even talking about? You know we're not.
Let me know if you have a problem getting to that standard form.
Yeah, it's supposed to be one. Yeah, it's supposed to be one. I really wish this was one.
Okay, we need our center.
You better wings. Just catch.
Vertices, foci, make the transverse and conjugate
Boy Scout.
axes, eccentricity, equations of the asymptotes. That might be it.
I'll go with her.
How's Brownie? Sam?
What's a cross?
Did you get the standard form? Where's your center? 1, -2. 1, -2.
Oh, you did it.
No, it's an award.
To build the box,
Sweet.
you're gonna go sideways,
Wait, that's so great.
3,
We have to see if she loves.
and up and down, 6.
Don't know why Dan.
You see it becomes so tight.
And that happened. I had like tan colored shirt. I looked like red.
And I'm out of room.
How does Annabelle know when you know? Oh, dang it. This is supposed to be there, just to let you know. Wait, what? If this is 4, how is that a -1?
Oh, factored a -1 out.
Yes. No, I was saying it's x -1. Yeah, yeah.
Which way is this thing open? Sideways. So it's a big fat one. So in the blank that says vertices, what are you gonna put in that blank? What are the vertices? -2, -2, and 4, -2. Only 2 vertices, those are the 2. Center to focus. This time around, the center to focus is square root of 45. 3 root 5. So we're gonna start at the center. Please remember, everything comes from the center. So we're gonna start at the center, and we're gonna come back and forward 3√5. So what will be the coordinates here if we do that?
1, -2 plus square root.
1 minus 3√5, comma, -2, and 1 plus 3√5, -2. How come I'm adding the 3√5 to the 1? Because I'm going in the x direction. So of course I'm going to add it to the x. What's your eccentricity? 3√5 over this distance, which is what? How far is it from the center to the vertex? 3.
No,
So that one reduces. Sometimes your eccentricity reduces.
I would probably so.
What's the slope of your asymptotes? We went up 6 and over 3. So the slope is 2. So one slope is +2, one slope is -2. What point are you going to use when you write the equation of your lines? 1, -2. And this is 2 separate problems. And you will do either point slope or slope intercept. So I'll do one of them here. I'll just do this one. I'll say y plus 2 equals 2 times x minus 1. So y plus 2 equals 2x minus 2. Y equals 2x minus 4. That's one of our lines. I'll do this one with point slope. Slope intercept. So -2 equals -2 times 1 plus b. So this one is y equals -2x. Here are your 2 asymptotes. I did one each way so that I don't know which way you like best. Okay, well, you've got 4 minutes. You can start your homework. A little head start on that. John, you turn that off.